afternoon, guys. Today we are going to solve a problem on constructing a binary tree from in-order and post-order traversals. So this is one of the most important concepts of binary tree, where we have to understand how a post-order traversal works and an in-order traversal works, and these are all traversing techniques. So basically we will be given two arrays. One is the in-order arrays and the post-order array. Now the output is to make a binary tree in such a way that we are constructing like post-order traversal from in-order traversal, right? So basically let's understand this, how the post-order in-order traversal works and the tree and everything else. So you can see first you have two steps. So there will be some steps, okay, which I will be following. So first you can see there is like the n is equals to 8, which is the number of elements of the array. So in the in-order traversal you can see like 4, 8, 2, 5, 1, 6, 3, 7 elements are present, and post-order the elements are 8, 4, 5, 2, 6, 7, 3 and 1 are present. So when they are making the graph, you can clearly see one thing, that they are making it in a certain fashion. So first 1 is coming. So how to make this graph is also one of the important part of the understanding the data structure. So in order to understand the data structure, you need to know how this graph is being formed. Only then you can print the output as 1, 2, 4, 8, 5, 3, 6, 7. So there is no possible way you will going to print this output without not knowing this, how exactly it starts. So basically first we have to take the take the element from this side, okay? So whenever we are moving from we are moving from here, like from here to here, what basically we are checking is we will start from this point or this route, okay? So which is 1. So whenever we in post order, whenever we are starting from 1, we have to be very sure that we are starting from 1. So our starting element of the route will be 1 over here. Then you can see 2 and 3 is coming, okay? So how 2 and 3 and all those things are coming? Okay, so for understanding this thing, I will make it into some steps. So I will open a txt file, okay? So in this new txt file, basically what I'm going to show you is how this traversal and everything else is working. So first in my left, so whenever in post order, suppose in post order I am starting 1. So I'm starting with 1, starting with 1, okay? So 1 is present in 1 is present where in order traversal, right? So post order में say for example अगर हम लोग 1 से start कर रहे हैं, in post order we have to find कि in order traversal array में 1 कहाँ पे है. So you can see 1 is present in over here, somewhere over here, which is between 6, 3, 7, between 5 and 6. So उसको हम लोग left and right में divide कर देंगे. So left elements in this array will be 4, 8, 2, 5, 4, 8, 2, 5, and right elements in this particular array will be right equals to 6, 3, 7, right? So अगर हम लोग देखें 4, 8, 2, 5 लेफ्ट में है और 6, 3, 7 राइट में है. So अगर ये रूट है which is 1 on top, ये ट्री का हेड है, तो ट्री जब नेक्स्ट आइटरेशन पे आएगा तब 2 है एंड 3 है. How you are going to find 2 will be coming on the left and 2 right, 3 will be coming on the right. So हम लोग पहले ही देख सकते हैं कि 2 is present in the in-order traversal, right? So जब 1 से सबसे पहले which element we are encountering? So 1 के बाद which element we are encountering सबसे पहले? 2, right? 2. So our new node will be, new head equals to अगर 2 हो गया. So in 2, from 2 we will again check this array list. So 2 के left side में क्या क्या elements है, right side में क्या क्या elements है. 2 के left side में the elements which are left with respect to, ठीक है, 2 के with respect to में 4 आ जाएगा and 8 आ जाएगा, and 2 के with respect to में in order मतलब first array में with respect में right side में कौन कौन से आ जाएंगे, 5, क्योंकि 1 तो ऑलरेडी हो चुका है. So in that case जब रूट ब्रेक होगा तो लेफ्ट सब ट्री में 2 के बाद 4 आएगा, क्योंकि 4 सबसे पहले एनकाउंटर होगा, उसके बाद 8 आएगा, एंड राइट साइड में 5 सबसे पहले आएगा, ठीक है. सो वन दिस पार्ट ऑफ द सब ट्री इज डन. लेट्स कम राइट साइड में हमारा कौन कौन से है, 6, 3 एंड 7. 6, 3 एंड 7 में से सबसे पहले whenever we are going from over here, what we can see is we are encountering 3 as the smallest element. So अगर हम लोग 6, 3 एंड 7 में सबसे पहले हम लोग 6, 3 एंड 7 में से we are encountering with respect to 1, we are encountering 3 in post order traversal. So 3 is the first element. So whenever we are standing at 3, so अगर new head हमारा suppose new head equals to 3 है, then हम लोगों का लेफ्ट एंड राइट क्या बन जाएगा, लेफ्ट इक्वल्स टू 6 एंड राइट इक्वल्स टू 7. So in this way the tree is constructed. पहले एक एलिमेंट को हम लोगों को पोस्ट ऑर्डर की स्टार्टिंग नोड से उठाना पड़ेगा, फिर उसको इन ऑर्डर में उसकी पोजीशन देख चेक करना है, फिर उस पोजीशन के लेफ्ट साइड के एलिमेंट्स को लेफ्ट एरे में रखेंगे, राइट साइड के एलिमेंट्स को राइट एरे में रखेंगे. रखने के बाद वट एवर द एलिमेंट्स आर, उनको हम लोग जो पहले एनकाउंटर होंगे उनके सब ट्रीज बनाएंगे. ऐसे करके द ट्री इज बिंग मेड. Similarly, a second example is also there. You can try on your own. Okay. So over here you can see a node build tree is over given. In order array is taken as input. Post order array is taken as input, and size of the limit is also taken as input. Now I'm going to start with the code over here. So you can see, as per the problem statement, what we have done is we have created a search function. This is a linear search method. So the linear search method basically does, it searches element whether it is present in the array or not. So say for example we are putting value. Okay, so if value is found in a given array which is starting from start and ending from end, and if the individual elements are equals to value, what we can find out, we can easily find out one thing, that oh yes, this is like this equals to the value. That means we have to return the index where it is found out. So यहाँ पे we can write return the index where it is find out. Once this is done, if cannot return, if not find, if not find, not find, then -1. So let's come to the question. We have to build the tree, right? So here what we have done is a post index n-1, which denotes the last index. So you can see first I have to declare a class gfg. So in the class gfg, what I've done is a post index. So this is a global variable. So this is initialized. Once the post index equals to n-1 is declared, we can return the build tree helper or the recursive function over here. And recursive function build tree helper is basically having some parameters. This is the in-order array in, which is in the question you can see over here. Then post is the post order array. Then start is the starting index, end is the ending index. If the start value is greater than end value, what we can do is we can return it as null, because obviously the start value, the starting value or the starting index, suppose we are element array's first index is 0. Say for example somebody puts the first index of array as 44. So obviously it cannot be 44, right? So then it will return null. Then we are starting a node value, which is node has to be, the size of the node has to be the size of the post index. And what is post index is n-1 or the last element. So similarly what we can do is, if the start is equals to end, then we will return the root, or we will search it whether the index search in start, end and root dot data. It will basically search that particular thing in the in order array, or the in means the in order array. So when I was explaining you through this code that this is the in order array and this is the graph, so it means that whenever we are searching we have to see the in order array, right? So similarly we are searching the in order array. Now we have to recursively, as you have solved in other problems of linear search, to add the elements in the right and the left and build the particular tree by calling the particular function recursively. For movement of the indices, we have taken +1 for index movement. For the left movement of the build tree helper, we have taken the index -1 as the end of index. So you can see over here end is there, here also end is there, but here end is here in the right order. We have to start from index +1, and in the left, or building the left root, we have to start end at index -1. So similarly we are returning the root, and the root is basically this particular binary tree's root. So I hope you understood today's problem statement. We are looking forward to see you in our next video. So yeah.